All right, here we are at part 4 of the CROSLEY H17 radio here. Yes, 3 dog bones that were high in value, as I said in the beginning. Clipped them out of the circuit, retested them, and all of them read high. So they read high in circuit, they read high out of circuit. In this case, not all resistors will read high in circuit. Most of the time they'll read low because of the influence of other components. But in this case, no. There's some copper wire here that I had in the shop that I had to extend the leads on the replacement resistors that I had to put in here. So this is just the start of part 4. I've been kind of busy, and I just got through making a couple hours ago, making the video of the problem with the schematic not jiving with the radio itself. So I elected to just go ahead and replace component for component. And of course I referred back to the schematic on certain capacitors that keep saying capacitors, resistors that come off the plates and other elements of the tube, and I'm making sure that they are the correct value. And yes, they are, and I'm going to show you underneath here. I'm not done by any stretch, but here's what I did. These are 2 1000 ohm resistors in series that replaced the 2000. That would be, let's see here, this guy here. Okay? I didn't have a 2000. These are 2-watt resistors in series, so that's going to give me 2-watt resistors in series. It's still going to be 2 watts, but double the ohmage. So it's 1,000 here and 1,000 there. So that's 2,000. And you remember all that hanging in the air stuff down here. I brought all that up to this one terminal here. This is your 15,000 ohm. This is a 2-watter. I happen to have that. And the leads were short on that, so I had to add here. And what I did here is I sacrificed an old diode that I had in my junk box. I have many old diodes not marked. I clipped the lead off, hooked and pinched, and added it to this so it would reach over here, and slid some old style heat shrink tubing over it, which came out of some old equipment I junked a long time ago. Hooked and pinched right here. And it's away from the oscillator coil. Originally it was down here, but who knows what originally it was, because, you know, this radio has been worked on. You notice up here I've got the 47 microfarad electrolytic. Input, the positive side goes to the terminal strip. The negative is wrapped around the capacitor, which goes to ground, just like they had it. It was the most convenient place. I didn't want to tie it to the ground point here. Where am I here? Trying to read. Again, I don't ever think of putting my damn glasses on when I'm using the camera. So everything's all blurred when I'm looking at. I don't want to trust that because I had a hell of a time getting this screw tight to tighten up. It was a 440 screw with lock washers, you know, star washers under the screw and under the nut. But I couldn't get this thing tight. You know, it kept swiveling on me. So we'll rely on this ground because we know we're good here. And what I did is I put a jumper, off camera again, a jumper from here to here, because the terminals aren't big enough to get all these wires and components in there. So this is the positive and this is the positive, so they're both the same. And this end is the parts that were hanging in midair down here. The parts that were hanging in midair up here are all brought to this point here. I did not get to do any of these yet. I will. That's coming up. This resistor is body red, as I showed you on the last video, body red, and I couldn't find a dot because there is no dot. It's body red, end purple, and dot red, but there is no dot. So I looked it up, and it's 2,000 ohms, is it? I got it, yeah, 2,000 ohms. I don't know. I got to look at my cheat wheel. I can't remember now. I rely on that cheat wheel, otherwise I'm lost in the water. I'm dead in the water without it. Cannot remember my resistor codes. I never could. And I've been doing this stuff since the very, very late 50s and early 60s. And I always had to rely on some kind of a chart. It's like Morse code. It's a bunch of gibberish, and it cannot remember it. Okay. So, this resistor's fine. I extended... I'm off camera again. The problem is I'm looking in the viewfinder of the camera, and then I'm looking off the viewfinder and on the radio itself, and the camera gets moved and I'm off camera. This goes to the IF can. This was the lower section where everything was hanging, and I just extended it with good old hook and pinch, put another nice piece of old heat shrink on it. You can see some of the copper here. That's some of that copper wire I had. And save everything, so you never know when you're going to use it. So we got everything, this mess all straightened out. This resistor is right on the money. I can't remember what the value is. Yeah, okay, 300,000 ohms. It's not on the money. 300,000 ohms, it was reading 320,000. So my math is, I don't know, is that 10% or is that 20%? I don't know, but anyways, it's right on the money. I had to extend the lead on that too, you can see that. So we're not too bad off on this now. And of course, I think I showed you this already. That's done. This resistor was, oh, hang on a minute. Brown, black, and orange. 10,000 ohms. It read 13,000. And that's what it read in circuit. And when I clipped it out, it no change. 13,000. So we replaced it with this. So that's fine. We're looking good. We've got a little green job over here. That's going to be an SOB for me to get at. I have to try to, if I can rely on that schematic, find out what that is. That's really buried in there. Needless to say, if I have to replace it, it's not going to get tucked in like that. It's going to be going wherever it goes. And right now, I got my reading glasses on, but I can't tell where it goes. I cannot see where it goes at all. So when I play back these videos, I can see very clearly where everything goes. But not when I'm running the camera and with the magnification I have. But when you're doing it on a video, that's what I like about this camera, as I said, you really can get some good close-ups on it. This is the start of part number 4. We're going to be working up in this area later. Oh, I want to point out something. I've already mentioned this. This is not a flex resistor. This is the cable that goes to the 6Q7 tube, which is right here. And this is the inner cable, and then there's a shield right here. Okay, it goes down in the chassis. It comes out here. The shield is back here. And I put an ohm meter on it from here to the cap of the tube, and it's 0 ohms. So that is not a flex resistor, because I'm sure some of you are going to probably say on the other video that I put up there about you can't always go by the schematic. probably say, there's your flex resistor. Then I got to go and type out a response to that. I'm getting way behind on some of my comments on some of my other videos before these. So it is going to come to a point where I'm just not going to be able to respond to them. It's not that I don't want to. The comments get a little overwhelming, or when the text and the comment is so big, like some of you have done. I appreciate the info, but it's very hard for me to read these things, and so I skim over them. So please excuse me for that. It's very, very, very hard for me to read a lot of text. It's also been suggested in the past, not recently, that I should be putting these schematics on a tablet, which I do have, and read them from that. Well, that's a good idea. The problem is the gallery crashes all the time. You go to use it. Like, I got family pictures in there. You want to look at them. First thing you know, the gallery crashes. Unexpected error or something like that. It's an Android. So you can't rely on those things. Give me the good old paper schematics, and I will get them printed out. I just have to buy the ink, and it's probably $35 for the damn cartridge. It doesn't last very long. Can't do it now. So anyways, that's it, folks, on this part. Don't go away, because there's more to part number 4 here. So I just wanted to give you an update. We are coming along on it. It's almost at a point where I can probably plug it in and put the speaker in, put it on a dim bulb, and give it a try. All right, to continue on with part 4 here, we're feeding in from the ICO 950B, the B plus voltage going into the input filter. These filter capacitors are 450 volt rated. We slowly cranked it up off camera here. We got 422 going in. Needless to say, we don't have the rectifier in, and of course the radio naturally is not plugged in. This is something that I always do. I always apply the B plus on a radio that's turned off and not plugged in, not powered up in any way, to verify that there is no shorts in the B plus circuit. We established that. The input filter calls for a 300 volt. The second capacitor, 350 volt. We replaced them with 450, so the radio probably will not go over 350 when it's running. But right now, I just want to make sure everything's okay with steady 421 volts. We can crank it up a little bit more, but not over 450. Actually, the ICO's all the way up. So, don't think it puts out much more than that. You know, there shouldn't be a load on it. These are new caps. Yes, I'm touching the sides, not the wiring. They're running cold. And there's one up in here. We haven't done anything with this area yet. We are going to. But we are going to also put the cabinet on the bench, plug the speaker in, put the 5Y3 back in the socket, and we're going to bring it up on the dim bulb. Took me a little while to get the camera going here and everything. I have the meter hooked up to the B+. The ICO is turned off and disconnected. So this is the residual capacity charge that's in these electrolytics now. Slowly dropping. The most that ICO put out is 425 volts. That's the highest it'll go. That's why I want to make a power supply that will go out to about 450 or maybe 500, which will deliver more current than the ICO will, in order to power a radio's B+. Okay, so we're just going to let that go, and what I'm going to do is I'm going to flip the chassis over. And I can probably discharge this on the chassis here. Yep. Okay. That way we can take our clip lead out without having a problem with getting a shark. And we are going to try this radio out. Yeah, it's not done yet, but I'm confident that there is no B+ shorts. All right, this is not the best angle, and my body might be in the way. Volume is up all the way on it. And we got the dim bulb in circuit. And the dim bulb is dim. Lit a little bit more than it was when it was just lighting the tubes. Not sure if this 5Y3 is lighting. It don't look like it. So I might have a bad 5Y3, in which case I may not be able to locate one if I even have one. I think we have a bad 5Y3. Okay, I found a 5Y3. I didn't bother testing it because I have a lot of tubes that I have not tested. So it is a 5Y3. Can't use a 5U4 because 5U4 filaments draw 3 amps. The 5Y3 filaments draws 2 amps. So you could damage the power transformer, and at the very least it probably wouldn't supply the current to light the tube properly. So we are going to do the same thing again. We're going to see if it works. We don't know if this tube is any good or not. We will find out. The original one was burnt out because I tested the filament with the ohm meter. Well, it don't look like it looks like we got another dead one again. So I don't know why this guy said that this radio worked. It couldn't have. Now we're back to square one again. 2 1/8, I think, is the filament. I've got 1 ohm. The tube is warm, but it did not light. All right, that tube tested weak. It was right on the question mark, but it did light in the tester. So we're going to put the original one back in. I couldn't see it light in the radio. I can't imagine the filament winding would be burned out on the filament transformer, on the filament portion of the transformer. It's coming up. again on the weak side. I don't understand that. It's a possibility that maybe the speaker's shot. Maybe I am getting sound. Oh. No, I thought I forgot a tube. I got the tube here. Well, the tube seemed to have died here. Five Y 3, 51, 6, 4, and 3. 51, 6, 4, and 3. Socket 3. Oh, tube died. I lost my... So this 5Y3 seems to have died all of a sudden. That's the original one. 5Y3 is pretty hot. Let's put an antenna on this thing and stick a piece of wire on it. Before I do that, tube is reading very weak. I had trouble with this socket, and I wiggled it around. Now, when I first got this thing, I made a video on it and tightening the pins with a very small screwdriver and a needle and stuff. But obviously, this is a very well-used socket here, and it looks to me like we're going to have to change it because, see now, it's working now, but it's temperamental. It has given me problems on some octal tubes. But anyways, let's get an antenna on this thing here. All right, we don't seem to have anything on any bands here at all. Nothing. We got audio and that's it. Now, I did not test any of these tubes, except for the rectifier. This is the oscillator tube here, 6K6. That tube feels cold. They all do. I'm going to put the lights out and check and see if these are lit. Okay, I had the bypass turned on, so the voltage was low because I was going through the bulb. Now, a little more activity. This is on the broadcast. Yeah, a difference. And there's your 5Y3 lit right there. Okay, but the other 5Y3 was very, very weak anyways. The original one that was in the radio, which is this here. So, well, we got to do the rest of those resistors. I don't have the knob with me. I got it in the thing here in the box somewhere. Well, I managed to turn it without it. I sprayed some CRC cleaner in here. Somebody had suggested taking a business card and cleaning it. I'll do those things off camera. There's probably a short in here somewhere. There's another band here I'm on. Of course, I'm only on a little wire here. Let's get it on the band. Broadcast band again. Alright, well, we got more work to do under the chassis. So that's it for now. Okay, we have a resistor here that's supposed to be 3,000 ohms. Now, this here is not a flex resistor, as I said. This is the lead that goes to the 6Q7 tube grid. And then we've got a capacitor here, so you can test this in circuit. And it's supposed to be reading 3,000. And we're reading 41. Now, because this is in midair here, and there's no real way I can put a terminal strip in here, there's just no room. Normally I'd remove this. But instead, we need the strength of this dog bone to support this midair connection here, which is the way they did it, as I told you. So we're simply going to find a resistor. I got to do this by experimentation, and I'll do that off camera. We're going to shunt another resistor over the top of this, because like I say, we need this for support for this. So we're going to put another resistor across this to bring this down to 3,000 ohms. We're going to do that off camera and we'll be back. Then we're going to test these here. These are influenced by the other resistors here. So we may have to clip the ends. Unlike these, I did not have to clip the ends of these dog bones because the circuit was not influencing the readings. So these all read high, and it made no difference whether they were in circuit or not, as I said before in this video several times. So that's what we're going to do now. We're going to come back on the video when I get that, jump it out, and we get that down to 3,000 ohms. We'll come back and take another reading. Alright, we're using a piece of equipment we haven't used in quite some time. I think I got this off of eBay, I don't remember. It's a B&K substitution box. And the resistors are off value a little bit. We're set on 10 ohms here. And we're reading 11.8, so they are off. But this is what I used to use. Not this box, but I've had the Radio Shack ones. Back in the 60s and 70s, when I used to make noisemakers, I used to adjust all the resistors using this, got the resistor I need, and then put it into the circuit. So what we're going to do here is we're going to put these leads on this resistor right here, where my finger's pointing, okay? And we're going to get it to go to 3,000 ohms, or close enough, and then we can pick out a resistor, whatever this reads, and we'll put it in place. Alright, you remember me saying that I'm going to use a substitution box here? Well, something's going crazy here. That's nothing new with me. I am totally confused the way this is working. I'll go to any lengths to avoid complicated math which I do not understand. Resistors in parallel. Like when you put resistors in parallel, you have two 100 ohm resistors, and you put them in parallel, it's 50 ohms. Okay, we pretty well all know that. Okay. I've got a 3,000 ohm resistor here, but it reads 4,100 ohms. It's right here. I'm pointing in the wrong place here. Okay, here is the complication. I can't figure this out. What I have here, I'm going to turn the ohm meter on in a minute here. I have my B and K. I can keep these wires out of the camera thing here. I have my B and K substitution box. I think the indicator's over here. I'm sorry, I can't see what I'm doing. 2,200, okay? Now, before we do that, we'll switch out the box. We'll take the box out right now. The big clips, the black and the red clips here are the substitution box. We'll take that off. The green and the red are the ohm meter clip leads. So we'll put that on. The resistor is reading 4131. It was reading 4141 before, but no problem. It might be influenced by this capacitor. I don't know. But anyways, this is supposed to be a 3,000 ohm resistor. Okay. Now we're going to drop another resistor across it because I need the support. I can't cut that out and put a modern resistor in there. It'll flop all over the place. Okay. Now, this don't make sense. And I think it's going to make no sense to you guys either. Those of you who are in electronics. We may be getting this part number 4 out to you sooner than we think. Hang on a minute. We're going to shunt that resistor with 4,700 ohms. 4,700. This thing, all the resistors are reading high. So, you know, I knew that when I got it. Okay, so you look at the meter now, it's 4,134. I'm going to bring the jumper in. Can't see this. Jesus Christ. Now you tell me. Look at that. I got my face up on it with a magnifier. That is 5,290 ohms. Why is that reading higher than the 4,000 ohm resistor that's in there that's supposed to be 3,000? This don't make sense. We'll move it up to 6.8 thousand. It's actually 7,000. We'll move it up there. Now we're reading the 7,000. Aren't we supposed to be influenced by this 4,000 ohm resistor? That should be influencing that. No matter where I set this. Now I can understand if I drop down to 10 ohms here, which actually this will read 10. It reads 11.8. Okay, I'm on 10 ohms here now. Shunting 10 ohms across this. Okay, that makes sense. All right? But when I go over the value that this resistor is, it should be no higher than the 4,000 that this has been reading. No matter where I set this, on the upper ranges. Now we'll go to the next range here. So hang on a minute, because I got to look at this. 10.6K. Now how the heck can this thing read over 4,000 ohms? How can it even begin to read 4K? It don't make sense. Now let me take the box off of this. Okay? Now she's down to 4,000 ohms. I am stumped. So, I don't know what's going on. Again, this resistor goes to the grid. This is the grid wire, so it's just going to the grid cap of the tube. Has no influence on that whatsoever, and it's going to a cap on this side. That cap is only 001, I think, or something like that. I don't remember. So, I wanted to bring this down to 3,000 ohms. And I wanted to do it with the sub box. Can't do it. Can't do it. So taking the ohm meter and going to the box now, I took it off the resistor. I'm reading. The problem with this damn ohm meter is, way up in the top here, I can't see that. If it's on mega or kilo ohms, I cannot see that until I get my face right on it. It looks like 10.6K. Okay, so that's fine. This thing is on R times 1,000. Right there. Like I say, this box is off. So we're supposed to be 10,000. But I'm not worried about that being off. The idea is this will still read 10,000 if I put the resistor back in circuit. It's like that 4,000 ohm resistor is not even influencing. It's not even in circuit. So I don't know. I am confused. And with that, I'm going to end part number 4. I'll work on these resistors here and then try to fire it up. But we're not going to do that today on this episode. We've got to get this thing figured out. I don't know what I'm going to do. I'm going to have no choice. I'll have to cut that out of the circuit and put in a modern resistor, and this is going to be loose. There's nothing I can do. I wanted to leave this in and shunt it with another resistor to bring it down. It's reading high. I want to bring it down to 4,000 to 3,000 ohms instead of 4,100 ohms. And I thought I can just pick a resistor that would do that with the box. Can't do it. Can't do it. You can see the box reads okay on the dials. Disregard the fact that all the resistors in here are no doubt carbon comp and they all read high. But the point is, I got this set on 10,000 ohms. And all the years I've been doing this hobby, you take a 10,000 ohm resistor, which reads here, and you slap a 4,000 ohm resistor across it, it's still not going to read 10,000 ohms. But we'll hold that right in there. I'm holding it. Take my word for it. My hands are on it. Doesn't change it at all. This is a puzzler, and I'll bet you a lot of you guys can't figure it out either. You know, the strangest things happen to me. I don't know what it is. I must be jinxed. Thanks for watching, guys. We appreciate it. This concludes part number 4. Take care.